Because I'm not the most patient man in the world, today we are going to make some CNC clamps. If you guys have done any sort of CNC machining, you know that clamping is always some sort of a challenge on any part that you're machining. I got several times I ran into this instance where I have an entire plate that I want to machine. That's almost the whole size of my mill bed, and I want to make a fixture plate of it, or I need to machine around the entire perimeter or something of that sort, and the clamps always seem to get in the way. I've got around that several times by using toe clamps, which work fantastic. They grip great and they work great. Inevitably, I have machined them almost 100% of the time. So unless I build those into my model, and I really try to avoid them, and then have to machine that piece back off afterwards by refixturing it, I have inevitably machined a little bit off of them every single time. And they work great if I want to keep about an inch thick stock on the table, but if I want to machine down below that, then they're immediately in the way. So the idea is I'm going to make these little T-bolt reverse style clamps. I don't even know what to call them. I've seen them before, but I don't even know what to call them to order them, or even where I would order them from. So because I am wanting to get this thing machined, we're going to take a crack at making these today. So relatively simple. They essentially are just a T-bolt. So it's just a T-nut, sorry, that goes into the table. Relatively simple. It's just a T-nut that goes into the table. This has an Allen screw into it, but what I want to do is this Allen screw will not have threads going into it. What it will do is it'll have a fat end on it, like a keeper, and then when this pushes through, you will have a through hole going through your material that you can grab this and then thread it backwards into the material, essentially clamping it to the table just through this Allen screw. So we're going to just rip a few of these off, and I'll show you the process that that takes if you want to stick along for the journey. So this is the fixture plate we're going to machine. You can see that the entire perimeter of this has some sort of machining done to it. Typically, if I had a toe clamp here on the side, toe clamps here on the sides, this would hold it into place fairly well. But this is actually machined down to 1/2 inch thick, so the toe clamps that I have end up being about 1 inch tall. So I would run into those, or I would have to machine pockets, leave pockets there that I'd have to re-clamp this and then machine those back after the fact. So what I'm going to do is drill a couple of holes in the center of this thing, and then use those backwards Allen screws through there to actually clamp this directly to the table, and then I'm free to machine around this entire part, no problem. The T-slots in my Fadal, and actually conveniently in my Bridgeport, are both 9/16. So we're going to have to size some material first. That leaves the outside of the nut at 0.875, so 7/8 of an inch. I only have a offcut of 1 inch stock, so first thing we're going to do is size this, and we're just going to use the manual mill for this. I am going to leave this long, because after we machine this profile into this, I'm going to need to cut this in the bandsaw, so I need something to clamp onto. There's no point in cutting this to size now, and then I have nothing to hold on to in the bandsaw. So I'm just going to put this whole thing in the mill. We're going to size this down to 7/8, and then we'll start machining that profile. Now this cutter spins clockwise, so what I want to do is feed in this direction so the chips are flying away from me, and I guess away from the camera as well. So we're going to set this up and we'll start our first cut. because I want this material to be 7/8 by 7/8. If I leave this set at the exact height that my parallel was at, I can just flip this over and I don't have to reset my depth. So I'm going to cut one more pass down there and I should be left with something 7/8 by 7/8. Next we have to set the depth of this flange. So this flange measures 0.325. The way I'm going to set that is I'm going to take my end mill and touch it off on the top of this 7/8. So if I touch that until it stops, and then I'm going to set my depth here at the difference between 0.875 and 0.325 that I measured here, which is this wall that I want to take off. So 0.550. What I'll do is I will take my depth gauge up. Since this machine has no DRO at all, and I will measure 0.550 in this gap. And then lock that in. So now, when I come down the side, my depth stop will automatically stop me at that distance there, giving me my 0.375 or 325 on the bottom rather. Now we just got to set the inside depth and then we'll take a couple passes. Okay, I got it flipped over sitting on this tang and I'm going to drill my 3 holes. Now the difference between this T-nut and the one I showed you earlier is that T-nut was threaded so you could put the bolt down through the table. This one I need to have a smooth hole so the threads pull up the other side and thread into the workpiece. So we're going to drill a 7/16 hole through this and then we're going to enlarge the base of this to fit that shoulder that I'll show you next. So we're going to pop some holes in this first. So the last thing I got to do is bore my hole on the back side of this. That's the relief that stud can pull through. So that's getting bored to 9/16 because I don't want to break through the walls of the T. Normally what I would do is get a 9/16 end mill and run it through, but I don't have one handy, but I do have this annular cutter. So I'm just going to run that down. I set my depth the same way. So I set this on the top and then I dial in my depth up here, and then I can punch each hole to the exact same depth. So we'll just move this over. I did start each hole with a 9/16 drill bit just because the flat nature of that end mill, it'll walk all over that hole. So I started each one with a drill bit down maybe about 1/8 of an inch, and then I got a nice clean hole that this cutter. Last thing I did was just chamfer the edges of these real quick, just deburr these. So those turned out great. All I got to do now is cut them to length in the bandsaw, then I'll have 4 of these, and we're onto the studs. The studs, we are going to use these 7/16 set screws, or grub screw, whatever you want to call it. Now, the plan with these is I'm going to thread them into a 7/16 nut, leave exactly 3/4 of an inch sticking out, and then I'm going to weld this solid, and then we'll machine this back to the shoulder that we need. What's important about that is we need to have the hex on the top side of it. So it's going to look like a cap screw with the hex on the opposite end. So I've got this one welded already. So all I did was set this depth and then welded them to solid, chucked them into the lathe, and then I ended up having them look like this. So I have my shoulder on the end, exactly 1/4 of an inch thick, 5/8 diameter, with the all-important hex on the opposite end. So it looks exactly like a cap screw, except for the hex is on the opposite end. What that does is that fits into the hole here, and you can see it floats in that hole and threads into the plate above it. So this is completely free floating. So you can see that's completely free floating in there. And the idea is that threads into the plate above it, and then the shoulder stops it from pulling out through. So I'm going to machine up the last couple of these. I'm going to cut in the bandsaw, and then I've already got my plate drilled and tapped. So let's get this in the machine and see how it works. All right, moment of truth. Let's see how this thing fits. So you can see these little guys. That pops in and out of there. Put a pair of those in. So, like I said, I've already drilled and tapped the plate I'm going to machine. We'll put this in place. Make sure these are close to our holes. Slide her over. Now I suspect putting this through is going to be difficult to get the Allen key up and started in there. So I'll show you a little mechanics trick. Just a bit of wheel bearing grease on the end of that. Just enough to give it some suction here. Okay, took a little bit of screwing around, but man, that sucker is on there, and you can see there's nothing across that whole surface I can't machine. So let's indicate that plate, and we're going to start the program. So that's at our corner point, but you're familiar with the phrase trust but verify? Well, that doesn't hold any truer than in the CNC world. So what we're gonna do is check that offset and make sure it's set correctly. So we're gonna switch to a pointy tool. Then we're going to go into MDI mode and we're going to call up that offset. And then I'm going to just jog down that Z-axis to see if we hit it. I don't know if you can see that. Nailed it. So we got our offset right. I'm going to go over to the office and load the program, and then we're going to start cutting.